Yes. So yesterday we had introductory session on this Azure Databricks with PySpark. Why Databricks? Why Azure Databricks? What is Spark? Need for PySpark? PySpark features. Job market of Azure Databricks with PySpark. Just I'll take 2 minutes what I discussed in the last class. Before that, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yeah,
Fine. So Databricks, it provides Spark cluster. Cluster means a group of nodes systems connected in a network. So there are two types of nodes, driver node or master node or worker node or slave node. Here we follow master slave architecture. Here we follow master slave architecture. Single master and multiple slaves. If we have 40 node cluster, in that one will be the driver node and all the remaining will be the worker nodes. Data will be distributed across multiple worker nodes and these multiple worker nodes will be executed parallelly. So what is Spark? It's a very high speed processing execution model which process huge data at a quick time. So if you see the main features of Spark, in-memory computation means data and storage both happens in the memory level. Supports MPP, supports massive parallel process. Spark is 100 times faster than the normal disk processing. Assume if you have got a cluster with 100 nodes, this 100 nodes cluster, right? So what the processing? 1 TB of data at a time. Tomorrow your data volume has increased by huge amount. Same cluster if you are using, your speed goes down. Solution, scaling up the cluster by adding some 50 new nodes. So again 1 month, again data increased, again add 50 more nodes. So every time scaling up the physical data center is a complex task. So the solution, same cluster in the cloud and that too with auto scaling feature. Who is providing this? Databricks. Who is providing this? Databricks. Databricks provides Spark cluster with auto scaling feature. Today my organization data load requires 100 nodes. Tomorrow data volume increased. It has to be extended to 200 automatically. After processing, it's completed, then it has to revert back to 100 nodes. This is general Databricks. This is general Databricks. This is not compatible with all the Azure storage services. Means it cannot interact with all the Azure storage services like Azure SQL, Azure Data Lake, Azure Cosmos DB. Regular Databricks is not compatible. That's why Microsoft and Databricks collaboratively they launched a new product called Azure Databricks. Azure Databricks is a Spark cluster. Azure Databricks is what? It's a Spark cluster with auto scaling feature and compatible with all the Azure data storage services. Yes. For normal Databricks, we have to do a lot of other settings. We need to call these different APIs. Databricks not only available for Azure, but also available for AWS and Google. In Databricks, who is processing the data? Spark. So Azure Databricks is a Spark-based data analytics platform. It's a very high-speed processing execution model, I said. So if we take, there was a test done by this Yahoo to test the speed of different databases. It has taken a table of 100 TB consisting of 1024 columns. Task sorting based on 16 columns. Sorting based on 16 columns. What is the time taken by the different the time taken by Oracle to process this 100 TB data based on 16 columns, 3.5 days it has taken. MySQL has taken around 6 days. Teradata, a specialized data warehouse database used for data warehouse, right? It can handle this. Another specialized database used for data warehouse, Netija, uses 3 hours, right? So it has taken 3 hours time. Hadoop has just taken 3.4 minutes. Hadoop has just taken 3.4 minutes. Where this database have taken days of time, these have taken hours of time, these have taken minutes of time. Hadoop has just taken 3.4 minutes, means very high speed processing, right? So, but Spark is 100 times faster than Hadoop. Hadoop already has taken very less time, but Spark 100 times faster than that Hadoop map reduce we see. Why PySpark? I was talking yesterday, right? So Apache Spark. What is Apache Spark? Right, sir. So here PySpark. Why PySpark? PySpark is a Python API. It's a Python API to use Spark. So PySpark is one of the lightning fast technology that is designed for fast computation, very demanding tool among the data engineers. PySpark is used for running distributed SQL, creating data pipelines, ingesting data into database, running ML algorithms, working with graphs, and working with graph data streaming. So need for PySpark means, so huge data is getting generated. Lot of data is getting generated everywhere, right? So the data contains many hidden patterns, unknown correction, market trends, customer preferences, right? Or other useful information. This it is necessary to extract valuable information from this raw data. So we require some efficient tools for performing these type of operations, right? On big data. So PySpark is such a kind, right, which can crack huge data and gain benefits from it. So combining Spark and Python. That's why Apache Spark community came up with a tool called Apache Spark. Yes, PySpark. A real life usage. It is used in the commercial sector. It is used in the commercial sector like Apache Spark real-time processing in banks and other financial fields. They are using Apache Spark to retrieve that customer social media profile and analyzing or gaining useful insights, which can help in taking the right decisions. In healthcare, so here healthcare, right, even to analyze the patient's records along with the previous medical reports, right, to identify which patient is going to face that issue. Entertainment industry. The popular OTT platform like Netflix using Apache Spark for its real-time processing for this personalized online movies and web series. It's going to process 450 billion events per day over the server-side applications and trade and e-commerce. The leading e-commerce websites like Flipkart, Amazon, all this, they are using Apache Spark for its advertising. Tourism industry, right? Even Apache Spark is used here to provide advices to millions of travelers by comparing with hundreds of other websites. This is what we have discussed in the last class, right? This is what I have discussed in the last class. Yes. Okay. We see something. Okay. Evolution of Spark. Spark was developed by Matai Zeheria. Spark was developed by Matai Zeheria in AMB lab. It was developed by Matai Zeheria in AMB lab, Berkeley. In the year 2009, Spark was developed in the year 2009 in AMP lab, Berkeley. Spark was open sourced. Spark was open sourced in the year 2010. Spark was donated to Apache Software Foundation. In the year 2013. Spark was donated to Apache Software Foundation in the year 2020. Was open source in the year 2010, right? So if you want, I will define Spark in 5 lines. Defining Spark. Spark is a, I define Spark in 5 lines. Open source, distributed cluster computing framework. With in-memory computation. It's an open source distributed cluster computing framework with in-memory computation. in parallel process style. Used for large scale is an open source distributed cluster computing framework with in-memory computing features with parallel process style used for large scale data processing. What do you mean by in-memory computation? In-memory computation. In-memory computation means the data getting stored in memory and processed within the memory. So here, Spark data gets divided. Spark data gets divided into a Spark data. Multiple partitions. Spark data gets divided into multiple partitions and are distributed across Spark data gets divided into multiple partitions and they are distributed across multiple RAMs of multiple worker nodes and are processed parallelly. Because of which we see very high speed. Other in-memory computing systems. Other in-memory computing systems. SAP HANA. SAP HANA. Other in-memory computing systems, SAP HANA, right? Yes. If you talk about the comparing both, both are in-memory computing systems. Both are in-memory computing systems. But in SAP HANA, but in SAP HANA, we don't see distributed RAM like Spark. Distributed RAM like Spark. So Spark has high speed. So Spark has high speed. So Spark has 1 second. Spark has high speed because of distributed RAM. So I'll compare this Spark with the different other technologies, right? So before comparing, right, Spark can be implemented. Spark can be implemented. Spark can be implemented or coded. Spark can be implemented or coded with hmm, can be Scala language, Python language, Java language, or language. Spark can be implemented or coded with Scala, Python, Java, or language. By default, Spark built using Scala. So both the Spark with Scala and Spark with Python are mostly used today. By default, Spark built using Scala language. Today, Spark with Scala and Spark with Python are mostly chosen, right? The Spark with Python, PySpark, we say, right? So if you compare the Spark with different other technologies, if you see the different execution engines, right? Yes. So if I talk about Spark and Sage, there's one more programming. There's one more Spark and Sage. What is the commonality between these two Spark and Sages? Both, both follows, both follows DAG model. Both follows DAG model. DAG model means directed acyclic graph model. Directed both follows DAG model. Directed acyclic graph model. but Tej doesn't support. Tej doesn't support in-memory computation. Tej doesn't support in-memory computations. So Spark has high speed. Spark has high speed as compared with Tej. So Spark and Tej both follows commonality between these two is both follows tag model, but Tej doesn't support in-memory. Spark has high speed as compared with Tej. Spark and Hadoop. In Hadoop, we have got a map reduce if you have got knowledge on this. Spark versus Hadoop. We talk about the drawbacks. Generally, Hadoop has got very high speed. Just now I given an example, right? As compared with other databases where they have taken days and hours of time, Hadoop has just taken minutes of time. First thing, transformations cannot be reused. Transformations cannot be reused. Transformations cannot be reused means in the case of Spark, one of the important thing what we see here is if you have executed a transformation, that output again can be reused. Transformations can be reused in the case of Spark, but in the case of Hadoop, transformations, if you have already executed, again we need to re-execute it, but we cannot already used transformations output can't be reused. And secondly, bad for iterative algorithm. Bad for iterative algorithm. Bad for iterative algorithms. Iterative algorithms means the name itself saying iterative. Most of these machine learning algorithms are iterative in nature, but Hadoop is bad for this iterative kind of algorithms. Means whenever you apply any algorithm, like you will get some error. You keep on applying it iteratively. Not a flexible parallel process. Not a flexible parallel process. Why it is not a flexible parallel process means it has got map reduce execution, mapper phase, reducer phase, mapper phase and reducer phase. One after the other they need to execute, but they cannot execute parallelly. First mapper phase should execute, next comes reducer phase. The reducer phase output will be collected. Without executing mapper, reducer phase can't be executed. So that's why it's not executing parallelly, sequentially. First mapper phase, next reducer phase is going to be executed. So that's why I'm saying it's not a flexible parallel process. Spark is 100 times faster. So there is one more component, if we Spark comparison with Apache Pig. Apache Spark, Apache Pig. The commonality what we see between these two, Spark and Apache Pig. Apache Pig also it was a very we have got pig Latin language we used to say, right? Both commonality between these both are data flow languages. Both are data flow languages. See, the importance of pig. If you see in the year like 2013, 14, 15, right? Mostly like Apache Pig was mostly preferred. Means previously in MapReduce, right? Lot of Java code we used to write, but here Pig, we have got Pig Latin language, 100 lines of Java code. We can just write within 6 to 7 lines in Python. Sorry, in Apache Pig, right? In Apache Pig, we have got Pig Latin language. Pig Latin language. Pig Latin language means it's a scripting language. Pig Latin language is scripting language. Like very, very less coding we used to see. Around 100 lines of Java code we can write within 6 to 7 lines using this Pig Latin. So that developers got attracted towards the Pig Latin and Apache Pig because of this very less coding, right? But slowly when Apache Spark was introduced, Apache Pig got outdated. Both are data flow language only. But in Pig, entire data flow. But in Pig, entire data flow will be converted into one Hadoop MR job. Into one Hadoop MR job. Already we said, right? Already Hadoop MR has drawback. What is the drawback we see in Pig means? Yes. Already Hadoop MR has got drawback. Again, it is converting into Hadoop MR job and executes. MR job means MapReduce. See, if you talk like, okay, Apache Spark.
What is this data flow language?
Data flow is a sequence collection of pipes. What do you mean by data flow means? Sequence collection of pipe. At each pipe, any data operation, like data loading, data merging, data filtering, data transformation, data grouping, right, is going to happen. Data flow means the output of one will be the input to the next. Again, that output will be the input to the next. See, very simple. You perform, okay, data flow language. You perform some transformation. The output of it taken as input by the next trans. The output of one taken as input by the next transformation. So series of transformation you are performing. In the first one, you are performing some loading, in second one filtering, in third one some grouping. In this way, some series of transformation. So it's a data flow. This entire data flow, it has to be converted into one MapReduce job. So it has to convert it into so it gets converted into that MapReduce job and executes. That's why MapReduce is bad for that. Already I said some drawbacks. That's why even Pig also has got drawbacks. So data flow, nothing but sequence collection of pipes. At each pipe, any one data operation is going to be performing. The output of it will be the input to that. Even in Spark also, the output of one will be the input to the next one. The output of one transformation will be the input to the next one. So both are data flow languages. But in the case of PIC, again, it's converted into MapReduce, because of which there's a drawback for it. But once from 2016-17, right? There were like POCs, proof of concept, like POCs, many other things were started developing using Apache Spark. But 2016, 17, 18, see, initially Apache Spark built using Scala language. Mostly Scala was preferred in the initial days. Now today, like Python is mostly preferred because Python has got many libraries towards this machine learning and different other environments, right? Yes. So when Apache Spark was introduced, Apache Spark, see, Apache Spark was introduced. Immediately after introducing Spark, Apache has introduced one more product immediately called Apache Flink. Apache Flink. Apache Spark and Apache. The purpose and objective. The purpose or objective of both are same. Both are introduced by Apache only. But people, there was a big talk, right? When Apache Flink got introduced, right? They said there was a big talk that Spark is going, because Flink was dominating Spark. They were saying that Spark is going to be going away from the market and Flink is dominating Spark. It was true. It was true, right? Flink was dominating Spark in the in the earlier version of Spark. It was weaker. It was weaker, right? I can say in the initial versions, of Spark, Spark was weaker in data analytics. Data analytics. Spark was weaker in data analytics. The heart of this data analytics, machine learning, right? So it was weaker in the case of this analytics. So before there was Spark versions, right? Before Spark 1.6 version. Before Spark 1.6 version. Spark was down. Before Spark 1.6 version, Spark was dominated by Flink. Spark was dominated by Flink because Spark was weaker in the case of data analytics. But from Spark 1.6 version has got some powerful libraries were introduced for this machine learning, for graph algorithms, for SQL kind of querying. So Spark was made almost equal to Flink. Spark. But from Spark 2. But from Spark, again, Spark started dominating Flink. That's why you won't see that name Flink today. So Spark became very much powerful with powerful libraries were introduced for this That analytics, graph algorithms for streaming. Yes. Okay. Now talking about the Spark advantages. Spark is mainly designed for, before I go with advantages, right? Spark is mainly designed batch applications, for batch applications. So there are two types of applications. Batch applications, online applications. But Spark is not for online application. For example, when a transaction has happened for a single transaction for one record, two records, right? Record not for record level operations, not for online applications. Means online applications means user interactive applications. It is for mainly designed for batch applications. Batch, bulk, millions and trillions of records are involved, right? Yes. And user non-interactive applications, we call it as batch applications. Secondly, like iterative algorithms. Mainly designed for batch applications, iterative algorithms for interactive queries, for streaming, for graph algorithms. For graph algorithms, right? Yes. So Spark mainly designed for this, right? Batch, iterative algorithms, interactive queries like interactive for streaming. Now, finally, if you just say the advantages of Spark, what we discussed as compared with different technologies. In-memory computation, we can say yes. In-memory computation, right. Distributed execution, flexible parallel process, in-memory computation, distributed execution, flexible parallel process, very high speed. That's got very high speed. Multi-language support like Python, Scala, Java, or language. Good for iterative algorithms. supports advanced analytics. As compared to Tej, it has got in memory. In Tej, no in memory. So in the case of HANA, here we see distributed execution. There is no distributed ROM. As compared to Hadoop, flexible parallel process, very high speed as compared to this Hadoop MR, and good for iterative algorithms, supports advanced analytics, and transformations can be reused here. Transformations can be reused. So these are the advantages, right? Yes. So that's the reason compared with all the different other technologies, Spark has got very high speed, flexible parallel process, supports multi-language support, in-memory computation, distributed execution used for large-scale data processing. Okay. So in the tomorrow session, just I'll be briefing you about how exactly the process Spark data objects are getting processed, how they are getting divided into partitions, how they are processed, right? And parallelly, how they are processed parallelly. Spark data objects we call like RTDs and data frames. How that data is divided into partitions, how these partitions are distributed, and how they are running parallelly, and why it has got a very high speed. And what are the different things we can perform, right? We have got inbuilt transformations, inbuilt actions available, right? Yes. Can just check this course content, right? So tomorrow also everyone can attend the session same time using the same link to see more discussion, right? How this Spark data processing is going to happen. That I'll be briefing you tomorrow. Yes. Azure Databricks. So before I go with this data, I'll be giving some knowledge on this big data, Hadoop, Spark, cloud computing, right? And coming to this Azure Databricks, creating Databricks workspace, the Databricks service using Azure Service Resource Manager, and managing clusters, displaying clusters, starting, terminating, deleting cluster information, cluster logs, types of clusters, all-purpose cluster, job cluster, right? Yes, Databricks pools, clusters, different types, Databricks utilities, different types of utilities, Databricks integration with the Azure Data Lake, Azure SQL, Azure Synapse, Azure Blob Storage, and the PySpark data frame. So now PySpark data frame. So how to create data frame API, creating data frame, show, row class, column class, collect, select. In this way, we have got many functions. So all these many functions with many working examples. PySpark built-in functions, various built-in functions of PySpark and Databricks handling multiple file formats, CSV data, JSON data, Fargate files, Excel files, XML, ORC. Databricks batch processing, historical data load, incremental data load, aggregations, join operations, window functions, union operation, right? Yes. PySpark external sources working with the different things and integration with the MySQL, working with CSV, JSON, transformations and actions, narrow and wide transformations. Databricks streaming API. What is streaming? Process of streaming using PySpark API. Handling bad records. Databricks Lakehouse. Introduction to Delta Lake. Introduction to features of Delta Lake. Merge operations. SCD type 1, type 2. Handling data deduplications, workflows, and handling jobs, monitors, and Databricks. Right. This is in brief, in depth. I'll be discussing about Databricks with PySpark. So I was saying, right, So the timings, first 1 week, like it will be at 4 p.m. Later it will be at 5 p.m. I said. The offerings will be getting each and every session video, soft copy of this class notes, assignments and tasks to work. A WhatsApp group will be added to the WhatsApp group. A live interactive hands-on sessions. Okay, so tomorrow also everyone can attend the session, same timing, right at 4 p.m. to see more discussion. Tomorrow just I'll be entering into the technical aspects. Yeah, any queries you got anywhere, right?
So do we have is it Monday to Saturday or Monday to Friday, sir?
Monday to Friday. Sometimes on Saturdays I'll be taking, not all the Saturdays. Mostly Monday to Friday.
Thank you, sir.
Okay.
Python also we are going to use.
Pardon?
Python also we are going to use.
So yes, the prerequisites for this is like basic Python, basic SQL. Just need to have basic knowledge of that. So just I'll be taking some sessions, right, to brief you about the syntaxes of Python.
Okay.
Okay. So if I'm done with the queries, if there are no other queries, then I'll sign off for now. Meet you tomorrow, same time at 4 o'clock. We see more discussion. Tomorrow also everyone can attend the session, same time, right? Yes. Fine. Thank you all for your time. Meet you tomorrow.